Welcome to the DIY Honda Garage channel. The DTC P16BB, identified as Alternator B terminal circuit low voltage, pertains specifically to the Honda CRV models from 2011 to 2016. This code indicates a low voltage condition within the Alternator B terminal circuit, which is critical for the vehicle's charging system. The alternator plays a vital role by generating electrical power to charge the battery and supply the electrical systems while the engine is running. The alternator's B terminal is responsible for transmitting the generated voltage. Diagnosing this issue requires a systematic approach involving multiple pre-checks and verifications to identify any faults in the circuit or component failures. Before proceeding with troubleshooting, it is essential to gather all relevant diagnostic data, including freeze frame, onboard snapshots, and any history of DTCs stored in the vehicle's system, which sets the stage for effective troubleshooting. DTC P16BB indicates an electrical fault specifically related to the B terminal circuit of the alternator. The alternator is crucial as it generates electrical energy necessary for charging the vehicle's battery and powering electrical components when the engine is operational. The B terminal serves as the exit point for this electrical output, and any failure in this circuit can lead to inadequate charging or operation of vehicle systems. The alternator is typically located on the front of the engine, driven by the serpentine belt. Checking its connectivity is essential, especially at the alternator itself and the underhood fuse relay box where the circuit terminates. Accurate identification of the issue often involves checking various components and connections that may inhibit electrical flow. When troubleshooting DTC P16BB, several possible causes must be examined. The first common issue is poor connections or loose terminals at significant points, specifically at the alternator and the underhood fuse relay box. Such deficiencies can result in insufficient voltage reaching required components. Additionally, an open circuit in the wiring between the alternator and the fuse box could also lead to a low voltage condition, effectively disconnecting the alternator's output. If these aspects check out, the alternator itself may be defective, failing to generate adequate electrical power. Each of these causes needs to be systematically ruled out to effectively address the low voltage problem indicated by this diagnostic code. Vehicles experiencing DTC P16BB may exhibit a range of symptoms indicating electrical system issues. Dim headlights may signify that insufficient voltage is being generated, which can lead to poorly illuminated lights. Furthermore, multiple electrical systems could operate erratically or fail altogether due to low power supply, resulting in increased driver frustration and potential safety concerns. Additionally, the vehicle's battery warning light may illuminate on the dashboard, indicating the battery is not charging correctly, a clear sign that the alternator is not functioning as intended. All these symptoms align with a low voltage condition and warrant further investigation of the alternator and associated circuitry. The first step in troubleshooting DTC P16BB involves confirming the problem through systematic checks. Start by turning the ignition switch to the on-to position, ensuring that the vehicle's electrical systems are active without cranking the engine. Once the ignition is on, clear any existing DTCs using the Honda Diagnostic System, HDS, which will refresh the vehicle's computer status. After this, start the engine and replicate specific operating conditions. Turn on the air conditioning, set temperature control to maximum cool, adjust the blower fan to maximum speed, switch the headlights to high beam, and activate the rear window defogger. This simulation aims to put the vehicle under a typical load, which may trigger the DTC if the alternator cannot cope. Maintain the engine speed at 2,000 RPM for 1 minute to accurately assess system performance under these conditions. Lastly, use the HDS to check for any pending or confirmed DTCs that may arise from this cycle. The second step of troubleshooting DTC P16BB requires an in-depth examination of the +B terminal connections. Focus on identifying any poor connections or loose terminals at both the alternator and the underhood fuse/relay box, as these areas are critical for maintaining proper voltage flow. Visual inspections should highlight corrosion, damage, or accommodation inadequacies that could interfere with the electrical pathway. If the terminal checks confirm integrity and tight connections, proceed to the next troubleshooting step. However, if any flaws are detected, such as looseness or corrosion, it is essential to repair or tighten the corresponding connections to restore proper contact. This corrective measure is fundamental as it ensures electrical continuity, which is necessary for the alternator to function accurately. The third troubleshooting step involves a careful check for an open circuit within the wiring that connects the alternator to the underhood fuse relay box. This examination is vital, since an open in the +B line could clearly disrupt power delivery from the alternator. Utilize testing tools to check for continuity in the engine harness wiring. If continuity is confirmed, the alternator likely requires replacement as its failure is suspected. On the other hand, if an open circuit is detected anywhere in the wiring, appropriate repairs must be made to rectify the disconnection. Restoration of continuity is essential to ensure electrical flow from the alternator, thereby preventing any further voltage-related issues impacting vehicle performance. Once repairs have been made, it's essential to verify that they resolve the underlying problem indicated by DTC P16BB. Begin this verification by turning the ignition switch to the on-to position, which prepares the vehicle systems for assessment. Reset the powertrain control module, PCM, using the HDS. This action clears any stored fault codes. Following the reset, carry out the PCM idle learn procedure, which recalibrates the PCM to recognize the current operational conditions of the engine. Start the engine, observing the same load conditions as before. Turn on the AC, set temperature to maximum cool. Operate the blower fan at maximum speed and engage all electrical components involved in the previous tests. Hold the engine at 2,000 RPM for 1 minute once more to evaluate system efficiency. Afterward, utilize the HDS to check for the presence of any pending or confirmed DTCs to ascertain whether the initial issue has been resolved. Final repair verification is an essential step to confirm that the DTC P16BB has been resolved effectively. Begin by checking for the presence of any remaining or new DTC codes after the repairs and verification procedures have been completed. Should DTC P16BB or any other codes persist, it indicates an unresolved issue that may relate to poor connections or loose terminals at either the alternator or the underhood fuse relay box. A thorough examination of these areas is recommended to ensure that all connections are tight and free of corrosion. If all checks are clear, the system should be operating satisfactorily. Conclusively, if DTC P16BB does not reappear, it signifies successful rectification of the voltage issues initially observed, allowing the vehicle to restore optimal performance. Preventive maintenance is crucial to avoiding recurrence of issues like DTC P16BB associated with the alternator or electrical system. Regularly inspect connections to ensure they remain tight, clean, and free of corrosion or wear. Using dielectric grease can help protect terminals from environmental conditions that might promote corrosion. Additionally, keeping the alternator clean and free of debris enhances its operational efficiency, ensuring optimal power generation. Be proactive in monitoring electrical components' performance, including battery health and charging systems, to catch any potential issues before they escalate. Implementing these preventive measures significantly contributes to the longevity and reliability of your vehicle's electrical system. In conclusion, addressing DTC P16BB involves a structured and detailed troubleshooting process designed to isolate and resolve low-voltage issues within the alternator B terminal circuit. The diagnostic process begins with confirming the issue through careful observation and testing conditions. It emphasizes the critical examination of connections at the alternator and underhood fuse relay box, alongside the need for thorough wire checks. Repair steps must be carefully executed, following through with verification to ensure that the problem has been rectified and does not return. Preventive maintenance practices play a role in sustaining vehicle performance, reducing the likelihood of future issues. The systematic nature of this approach ensures higher accuracy in diagnosing and resolving electrical faults, leading to improved vehicle reliability. Please like and subscribe to the channel. See you next time.